In this video, we are trying to prove why the derivative of a constant function is 0 by using the definition of the derivative. So here we have given that the constant function f of x is equal to c, right? So our goal here is to show that if that is the function, then the derivative of that, let's say with respect to x, is actually equal to 0. So that's what it means here, right? So to show that the derivative of the constant function with respect to x is 0. So let's try to do that, and we're going to do that by using the definition of the derivative. So are we familiar with the definition of the derivative? So what was the definition, original definition of the derivative? If f of x is the function, then the derivative of that function, that means f prime of x, can be figured out by finding the limit of the difference quotient defined as f of x plus h minus f of x, right? And then divided by h. And then we need to take a limit of these at h approaches to, let's say, as h approaches to 0. So this is the definition of the function, and that's what we are going to use. And to prove this given function over here, to prove this relationship, or to prove this rule over here where the derivative of the constant is 0, let's assume that the function here is given as the constant. Okay, so by that said, so we can just use that function over here, f of x equal to c, and then use this definition over here to show that the derivative of the constant is 0. But how can we show this? How can we apply the definition over here? Well, if this is the definition, then we can actually first compute then what is the difference quotient. Once we compute the difference quotient, and then we can just take a limit as h approaches to 0, right? We can do that. So let's find the difference quotient first. So what do we need? What do we need here? We need to know what is the function. We already have that, right? We also need to find the function at x plus h. Let's do that. So if f of x equal to c, what is f of x plus h? If f of x equal to c, constant, right? So all the times the y value or the value of the function is the same constant wherever you evaluate. On that sense, f of x plus h will be also same constant, right? So that's how we have. So if that is the case, then what we can just do here is first let's try to compute this difference quotient over here, which is at the top, or at the numerator, we have f of x plus h, which we just say that is c, right? So instead of f of x plus h, then we can just write down constant. And then f of x is also c, right? Just the given constant over here. So if that is the case, instead of that, we can just write the constant. So there is a different sign between that. So we have constant minus constant. Underneath that, we have h, right? And then we just need to see if we can find the limit on this expression as h approaches to 0. But can we do that? So you can see here, what do we have here on this expression on the difference quotient? We have c minus c, which is 0, divided by h. But that is just equal to 0, right? And then if you try to find the limit of that as h approaches to 0, what will happen? Well, that is also equal to 0, right? Because the limit of the constant is 0. So on that case, we can instantly say that this is the derivative of the function if the function is constant, and that's exactly what we needed to prove here, right? We assume that the function is f of x is equal to c, so that's our assumption, right? Because we needed to find the derivative of that equal to 0, and it turns out that the derivative of that function, that constant function, is 0. So we proved that by this applying the definition of the derivative of the constant is 0.